Hi everyone, Mr. McIntyre here. This is Module 1, Section 4 on the distributive property. So the distributive property is one that I think you guys know, but we're going to review it anyway, so we're going to talk about some different uses for it. The main thing for the distributive property, it's for when you want to multiply one thing by more than one thing. Now, a lot of times we see it with variables, although it doesn't have to be with variables. But a very common distributive property type question is when you have a number, like the 5 here, out in front of something in parentheses, like the x plus 3. Now what it means, the way you would say that in words, it's a multiplication problem. It's 5 times x plus 3. And you can do it as two separate multiplication problems. You can do 5 times x plus 5 times 3. And in fact, one thing you're probably very used to, most people do this when they're doing the distributive property, they'll use little curvy arrows. They'll say, draw in this arrow to do the 5 times x, then draw in this arrow to do the 5 times 3. And that's usually what I do. If I'm working out a question and the notes are on the board in class, I usually do the little arrows to show my work. So for our first example, let's rewrite and simplify this problem right here. So what this question is saying in words is the number 4 times 3x minus 5, what you see in the parentheses. But it's actually two separate multiplication problems. It's 4 times 3x. Then I'm going to keep the sign in the middle. I'm going to do minus. And for the second half of the question, I'm going to do 4 times 5. Now 4 times 3x, when you're multiplying, if one of them has a variable, you just multiply the numbers. 4 times 3 is 12, and you leave the x on it. And 4 times 5 is 20. So I rewrote, I simplified. My final answer here is 12x minus 20. And that's the distributive property. But remember I said earlier, it's not only for variables. You can use it just with numbers. So yesterday we talked a little bit about mental math when we did, what were we doing? The properties, like associative property. You can do that with distributive property too. It can help you with things like multiplying or dividing bigger numbers. If you don't have a calculator or if you don't want to take the time to get your calculator out, this is a good way to do mental math. So let's say, for example, I wanted to do 7 times 23. Now, right off the bat in my head, that's a tough question. You know, if I'm trying to do 7 times 23, the way it's written in my head, it's hard. But what I can do is I can rewrite the question. Instead of 23, I can think of it as 20 plus 3. And then by the distributive property, now I'm saying, okay, so what I'm really doing here is I'm doing 7 times 20. I can do that in my head. I'm doing 7 times 3. I can do that in my head. And then I add them together. So to show work with the distributive property part, I'm doing 7 times 20. I'm doing 7 times 3. See, that's a lot easier. 7 times 23 I can't do in my head. 7 times 20 I can, that's 140. Because remember, it's just 7 times 2 is 14, then you stick the 0 on the end. And 7 times 3 is 21. So what it comes out to is 140 plus 21, it's 161. Now, maybe right now you're thinking, well, I still can't do that in my head. You know, that's a lot to remember. 7 times 20 is 140, this, that, you know. But as you practice and as you get used to it, you'll get better and better, and you will be able to do it. So this is kind of a beginning of mental math. You know, do I need to reach for a calculator every single time I see a multiplication problem? Or can I start breaking them apart into pieces and doing it in my head? Here's another example of the same question. I said, what would be a good way to multiply 6 times 298 without using a calculator or writing anything down? Now, Let me show you, based on what we did, like how it would match up with the last example, even though it's not the way I would do this question. You could do it as 6 times 200 plus 90 plus 8, and do a 3-part distributive property. You could say 6 times 200 is 1200, 6 times 90 is 540, 6 times 8 is 48. All of a sudden you're at a point, I can't do that in my head anymore. That's too much. Trying to remember 1200 plus 540 plus 48 more, that gets too hard. So let's say we're not going to do it this way. But then I look at it and I say, well, 298 is actually very close to 300. Maybe instead of adding, I'll do subtracting. So this is how I would do this question. I would do it as 6 times 300 minus 2. See, 6 times 300, I can do that. That's 1800. 6 times 2 is 12. Can I subtract that in my head? Can I do 1800 minus 12? Yeah, I can do that a lot easier than what I'd written the first time. So again, just to show work for this one, what I'm doing is 6 times 300. 6 times 3 is 18. Just add those two zeros, 1800, minus 6 times 2 is 12. So the whole answer to this question just becomes 1800 minus 12, which would be 1788, or 1788. So again, maybe you're not quite ready to do all this in your head yet, but you'll get there. As you guys keep going farther and farther in math, you can use this distributive property to start breaking things up, doing it piece by piece, and all of a sudden these math problems that you didn't think you could do in your head, you'll be able to. Now, there's one other thing I want to mention about distributive property. A lot of times when you're doing a distributive property, you end up with what are called like terms, and we want to combine those. So first of all, when I say like terms, what I mean is two parts of an expression that are exactly the same, except maybe the number part. If the variable part and the exponent part are exactly the same, we call them like terms. So for example, a nice easy example, 2x and 5x. Those are like terms because they both end with an x. So if I had 2x plus 5x, I can add those together. That's 7x. Then I gave you a much harder example. I said, well, these are also like terms. Now, the reason they're like terms is because the variable and exponent part is exactly the same in both. M to the third power n squared. Now, because they are like terms, you can add those together too. Just leave that variable part, leave the m to the third n squared, and just add the number part. And this is a little tricky for now. We're not going to do anything that difficult right now, but just so you guys can see the idea. Those are like terms, and I could add them together. So like terms can be combined, they can be added or subtracted, but unlike terms cannot. So just remember, if you have 2x and 5x squared, you can't add those together. Those are just different. They have to be exactly the same on the variable and exponent part. So for our last example today, let's simplify 12m minus 3 times m minus 5. And when I see the parentheses, I say, I'm going to do the order of operations says parentheses first. And a lot of times when you're doing parentheses, it means do distributive property. So I'm going to do the distributive property first. I'm going to take, let's do this. Let's count, it says minus. When you have a minus, you can kind of think of it as a negative number. So let's take this negative 3 here and do the distributive property. I'm going to leave the 12m, and then I'm going to multiply. So I do negative 3 times m would be negative 3m. So I'll put minus 3m. Then I'm going to do negative 3 times negative 5. Now negative times negative is positive. So negative 3 times negative 5 is positive, so I'm going to put plus 15. So that was the distributive property. It was a little trickier because we're distributing a negative number, but it's still distributive property. Negative 3 times m and negative 3 times negative 5. Now, I'm not done with the question though, because we talked about like terms. Right here, I have 12m, and right here, I have 3m. Those two purple ones are like terms. We can add them together. 12m minus 3m would give me 9m. 12 minus 3 is 9. Now the 15 doesn't have a like term, so just leave it. So my final answer for this question, 9m plus 15. And that's an example of the distributive property and combining like terms all wrapped up in the same question.